Well, thank you very much for the invitation to speak this evening. So my call is Kilo 8 Zulu Tango. As long as you don't bust my call, I don't care what you do to my name. My website's at K8ZT.com, and you can email me at K8ZT73@gmail.com. I'm located just northeast of Akron in Stowe, Ohio, and I volunteer for the Cuyahoga Valley Scenic Railway, so that's what you're seeing me in my uniform here. The slideshow has a number of links in it. If you use this link, tiny.cc/worst-ant, or you shoot the QR code with your phone, that'll give you access to the slideshow and all of the links that are in it. I'll have this at the end of the slideshow also. So jump right in. The worst antenna by far, no antenna. There's no question about it. The worst antenna is no antenna at all. But there's some other ones that are almost as bad. And that's when you had the idea that I really should buy an antenna, but it's still sitting in the package or it's sitting unassembled from when you brought it home.
I have number 2 and 3.
Number 3 is when the antenna is assembled but not installed. When it's not connected to anything, it doesn't help anything except for attract lightning, so you probably want to connect it at least and get a little bit of work out of it. They get a little bit different as we go along the list here. Number 4 is an antenna that's improperly assembled or too complicated to finish assembly. I have one of these sitting in my garage right now. It's a number of sliding aluminum tubes. They gave no starting dimensions at all, so tuning it up for 4 bands is going to be a challenge, and I haven't gotten around to it. Number 5. Number 5 is an antenna that's improperly installed or used poor feed line for. You buy that $1,800 beam, you put it up on that 60-foot tower, and you pull out the coax that you got at the clearance at Radio Shack, the RG59. It's been up in the attic for 30 plus years, and the rodents have been chewing on it. Not a wise move. Number 6 is an antenna that requires a counterpoise that doesn't have one. Now let me explain a little bit about this, because you notice I didn't say ground, I didn't say radio field, I said counterpoise. Because some antennas are designed with a counterpoise already built in. For example, a dipole antenna, one of the 2 legs on the dipole is actually the counterpoise. So it's already built into the antenna. There's no way to make a dipole without inadvertently creating the counterpoise at the same time. But an end-fed antenna might use a number of things as the counterpoise. It may use the coax line, shield as the counterpoise. It may have a separate counterpoise. When we think about counterpoises, most of the time people think about that radial field under a vertical antenna. A vertical antenna is only one half of the antenna. The other half is the ground return. Now, we don't need to put radials down. We can get a good, if we have a really conductive ground underneath it, like it's on a saltwater marsh or it's sitting in the middle of the ocean, it would have great conductivity back to the antenna from the ground or the water. Unfortunately, most of the ground is not perfect conductor of electricity. Matter of fact, many of our grounds are extremely poor conductors of electricity. So what we need is we need to help the ground along by putting out a counterpoise, or in many cases a radial field. Now, even some verticals though don't need a counterpoise because it's built in. If you have a vertical that's fed from the middle, it may not in fact be a vertical, it may be a vertical dipole. And the dipole again has its built-in counterpoise, so the lower half of the antenna actually acts as a counterpoise. Some verticals are designed with little radials sticking out of the sides of them, and those are the counterpoise. So if an antenna is required to have a counterpoise, you need to put one there. Now, the thing that a lot of people say, well, the SWR was just fine without the counterpoise. The SWR does not tell you anything about the efficiency or effectiveness of the antenna. It simply tells you where your signal is going, and it may be all being absorbed as opposed to being radiated back to you. So that's not a good indicator. Number 7 is no antenna for the desired band. First of all, some people say, well, that's a real pain to have multiple antennas for those bands, but think of the advantage we have as amateur radio operators. We're one of the few users of the radio spectrum that gets 11 HF bands and lower VHF bands available to us. That means we can pick and choose a band that is open during this specific solar conditions and has a target of a specific geographic location around the world. So by having those multiple bands, we increase our chances of being able to communicate, and that's a really good thing. But the bad thing is that means we need to have more antennas. Now, some antennas can work on multiple bands. Some of them are designed to do that. Some of them use traps, so there's actually multiple antennas in that antenna you're looking at, and each of the traps effectively cuts the antenna up into segments and provides one resonating segment for each of the bands that you're using. Another thing that a lot of people don't realize is sometimes you may have an antenna for a band and not even realize it. For example, a 40-meter dipole will work on 15 meters pretty well. Not perfect, but it'll work perfectly fine to get along. And many of you might not have a 160-meter antenna, but you may have an 80-meter dipole up. If you take that 80-meter dipole and feed it as a long wire, by feeding both of the two ends and using a counterpoise underneath it, it might work just fine. For many years, I did not have a 6-meter antenna. I had a little 10-meter beam, and with an antenna tuner, I worked 48 states with it. So sometimes you might have an antenna and not even realize it. But it's a great idea to have an antenna specifically designed for each band you want to work. Number 8. Now you might think I'm getting rather esoteric here, and that's the wrong takeoff angle for a target area, geographic area. Now, sometimes that sounds like, oh, that's getting really picky, Anthony, but right now I have a 43-foot vertical in the backyard. It works from 160 to 10 meters. I say that with a hesitance in my voice because what it does on 10 meters is it shoots the signal directly up into the air. And guess where it comes back down? Directly back down the air, to ground. So my 10-meter signal on this 43-foot vertical is horrendous. It's not going in the right direction. And that's just an extreme example, but another example you might see if you go by a big contesting station or you look at videos of something like K3LR's stacked 20-meter Yagis, 5 stacked 20-meter Yagis on a 200-foot tower. And you think, well, adding all those up increases the signal. Well, it does, but what they actually do, in addition to adding them all up, they pick and choose which of the ones they want to use. So they have it set up so they can select any of the series of 4 or 5 antennas and pick the ones they want. By doing that, antennas at different heights have different radiation takeoff angles, and they can target it to the specific area. So sometimes by picking the bottom 2 antennas, they might have a much better signal than the top 2 antennas. Unfortunately, most of us don't have 220-foot towers with 5 stacked 20-meter Yagis on it, but still, paying a little bit of attention to the takeoff angle can make a great difference. Another area that the takeoff angle is very important is with a dipole antenna, a horizontal antenna like a dipole. It should be at least a quarter wavelength above ground. Now, when you think about that, on 160 meters, that means it needs to be 40 meters. That means it needs to be 120 feet in the air. Anything lower than that, and the antenna starts to have a very high takeoff angle. That's why horizontal dipoles are not very popular on 160 because of the takeoff angle, whereas an inverted L or a vertical would have a much better takeoff angle for that. A lot of times we talk about NVIS antennas, near vertical incidence skywave antennas, and we often talk about that for 80 meters. Well, I'll tell you right now, unless your 80-meter antenna is up over 60 feet in the air, you're probably using an NVIS 80-meter antenna. That doesn't mean it can't go further out, but the takeoff angle is probably not optimized. Number 9, no backup antenna in portable field operation. And this goes back to another presentation I have on portable operations. And as I said before, there's links in the slideshow. When you click on the links, it'll take you out to them. And this is a whole presentation on portable operations. And somewhere in there, about 2/3 of the way through, I talk about 2 is 1 and 1 is none. So if you go out and operate POTA or you go out and operate field day and you bring 1 antenna with you and it fails, how many antennas do you have left? Well, none. And how many contacts are you going to make? None. So having a backup antenna for portable operations is very useful, even if it's a very suboptimal antenna. But you don't have to have a bad second antenna. It can be a different second antenna. So quite often when I go out in the field for POTA, I use an end-fed half-wave antenna and I use a vertical antenna. So I have 2 different radiation patterns, and if one antenna is not working, I can switch to the other antenna. Number 10. An antenna that's ready to fall down soon. This is when you did everything right the first time, but that's many years ago, and things do age. Damaged or abused coax, worn or bad hardware, worn or bad support structure, no weatherproofing or worn out weatherproofing, no maintenance, etc. can all be problems. That 10-meter antenna I was talking about before had a single element, it was a 3-element beam, and each of the elements fed through the mast pipe. They had a brass bolt in the center that held them in place. Well, what happened is I had mourning doves that loved to stand out on the end of my antenna and bounce up and down. Eventually, they wore those little brass bolts out, and they actually slid the elements out of the mast. So again, it requires maintenance. Now, since I put this together in April of 2023, last year in August, I had to add number 11, and that's when an antenna crashes to the ground. Unfortunately, I added this slide after a very strong windstorm on August 25th, 2023, brought down my tower, my beam, and my wire sloper that was also on there. This is not the way a tower usually falls, by the way. Typically, it crumbles anywhere from 1/3 to 2/3 of the way up, and it travels about 40% of the distance. This 50-foot tower actually went about 60 feet into the neighbor's yard because the wind grabbed it, snapped it off at the base, and the only thing that kept it from going further was the aircraft steel cable that runs up to run the hazer unit at the top. Or this would have probably did a Wizard of Oz and flew a couple streets away from my house. We had 2 major gusts of wind less than 1 minute, and it destroyed things throughout the neighborhood. Almost everyone had tree damage. I had a tree hit the front of my house. That wasn't my worst thought, but the antenna was. So this changed things dramatically. So how can you make it better? Let's count the ways, and let's think about some things that you can do to have something better than the 10 worst antennas. The first thing is, I suggest you get one antenna up and working. You can always upgrade it later. A simple dipole or end-fed wire can be easily, inexpensively, and an easy, inexpensive starting point. So getting that first antenna up. When I teach a lot of classes to new hams, and there's 2 things I always tell them. When they're thinking about buying that first radio, I always explain to them that's probably not going to be the last radio you buy. And I guarantee them when they start putting up antennas, that first antenna will probably not be the last antenna they put up. So don't worry too much about getting the first antenna perfect. Get something up and then work forward from there. So number 2, take the time to do it properly though. Assemble it according to the directions. If you're making a dipole, make sure you cut it properly. And remember that antennas need to be tuned. And tuning an antenna may change drastically at different heights or locations, and by being close to the antenna while you're retuning it. So you have to step back from the antenna, you may have to get it up in the air, and you may have to retune a number of times to finally get it working properly. Number 3, keep it simple, Sam. Simple wire antennas, single band antennas, avoiding complex designs, and avoiding severe compromises are good starting points for anyone just starting out. And here's a simple dipole antenna. In this particular diagram, there's fancy little glass insulators at both ends and in the middle. But instead, you can go down to the Dollar Tree and spend $1.25 and buy a plastic cutting board. Bring it home, cut out a triangle for the middle section. You can attach both of the 2 ends of the dipole, and you can also use it to hold on to the coax on the bottom. You could also cut 2 small pieces of that same cutting board and use them on the end for the end insulators. Or you can go out and buy these fancy glass insulators. But I'm telling you right now, you're going to be experimenting, so you need to learn how to utilize what's in your environment. I build a lot of my antennas out of parts that I find at dollar stores, hardware stores, flea markets, etc. And remember what I said earlier, this dipole is going to come down eventually. No matter what you do, it's not going to stay up forever. And even if it does stay up forever, you probably lost a connection at one end or the other and it's not functioning properly. So take it down and look at it every once in a while. One of the tricks I like to do when I'm putting up a dipole or a wire antenna is I like to use a rather inexpensive bungee cord somewhere in the system. So that breaks first before the wire breaks. It's very easy to go out there and reattach a new bungee cord, pull the pulley back up again into the air, and that way nothing is broken except for my inexpensive bungee cord, and it gives a little bit when the antenna swings in the wind. So here's the dimensions. You'll notice, of course, the higher the frequency, the shorter the dipole. And dipoles, on the higher bands, like 12 meters, I'm sorry, 6 meters, the longest and shortest lengths across the whole band are rather close. So here we look at 4.7 feet, 4.3 feet. The middle of the band is 4.5 feet. That would be perfectly fine to cut your dipole and use it across the entire 6-meter band. Now, when you get down to some of these longer frequency bands, the lower frequency bands like 160, you'll notice that the bottom end of the band is 130 feet, the middle is 117, and the top of the band is 123 feet. So notice there's a considerable difference of about 7 feet. And that's not even the worst one by percentage. Some of these are worse by percentage quite a bit. So be aware that depending on which part of the band you want to use, you may need to trim your antenna differently. Matter of fact, a lot of people don't refer to 80 meters as 80 meters. They refer to the upper portion, the phone portion, as 75 meters because it's so significantly different in length. Oh, by the way, if you don't have enough horizontal space to set up this dipole, set it up as an inverted V. That means a couple things. One, you only need one tall support in the center, and two, the total horizontal run will be much less. I have 2 links here. You can click on the links. This is a whole information on building a basic dipole. Everything you need to know about putting together a dipole, hanging up the dipole, using the dipole. The second one is another link on from Ham Radio School. This is by Bob's K0NR, and he always has a lot of good articles. Just talks about your first basic dipole antenna. I mentioned earlier you want to avoid severe compromises. And unfortunately, for a lot of new hams, antennas provide the biggest challenge. HF antennas. VHF antennas are simple. They're small. It's not a problem. But on HF, all of a sudden you have to put something very big outside, and it becomes problematic for a lot of reasons. One, your property may be too small. Two, you may have limitations on what you can do because of homeowners associations or significant others that live with you that don't care for the design of your antenna, or a neighbor that doesn't care for it. So we try and make compromises to make it easier. So the first compromise is we try and make it smaller, and if you try and make it too small, it really doesn't work well. The second one is skimping on support structure. This usually means you're putting it at a much lower height, and remember we talked about when you bring that antenna down, the signal, the takeoff angle is going to change drastically, especially on the lower bands. Also, it might have a low SWR, but antenna efficiency and size matter more. The best way to think about the size issue is from the antenna's point of view. In receiving signals, not in transmitting, in receiving. Think about it for a second. If I said I want to receive the maximum amount of energy, what do I want to do? I want to put up the maximum size of antenna for the specific frequency I'm using it at. So whenever we try and shorten things, make things smaller, bring things down closer to the ground, we lose in efficiency and effectiveness. Wouldn't it be nice if we could have a simple little box? This is full size right here, this little box with this whip that extends to about, maybe 3 feet. And it works all the way from 80 meters up into 440. This one has 2 little knobs you twist on it, and you can adjust it so you get a low SWR. Do you get an efficient antenna with these? Definitely not. And the higher the lower the frequency, the longer the wavelength, the less effective it's going to be. Now, do these work? I have one just like this, except for mine's even simpler. It only has 1 knob on it. Have I made contacts with it? Yes. Have I made DX contacts with it? Yes. Would I have had a much easier time making that same contact with a dipole? Probably 10 times easier. So these will work, but they're severe compromises. The other problem we run into a lot of times is something very simple is made very complicated by the marketing department. So here we have the spectacular long reach random length of antenna wire. And they say things like the best straight wire available, perfect for stringing between trees, highly accurate, easy to install, premium selectivity, optimized for ham radio by our unique process. And of course, you are 599, old man. Actual products may vary. This is, of course, a fictitious company called the Wet Noodle Company, but this kind of hype occurs all the time. And you can go out and spend $300 for a wire antenna that you could have put together for about $10 or $15. And guess which one works better? They both work the same. And if you don't have $300, I can guarantee the $300 was not going to work because you won't be able to buy it, so you won't have that antenna. So I mentioned you could work up with a compromised antenna, and some of you old timers may have been taught by your Elmers a great way to tune up your radio is use a light bulb as a dummy load. And some of you may have tried this and be surprised that someone came back to you in response because your signal got out on a light bulb. And this gentleman, David Day, has a whole website where he devotes information to the best light bulbs for long distance communications. And he talks about different light bulbs and coil arrangements he's done. He shows maps of where he's talked in the world. And you can talk with anything in the world, and he has which light bulbs work the best. So they have a light bulb contest. So that doesn't mean you can't make contacts with a compromised antenna. It's just harder. There's a great YouTube here by VA3 OSO, and I'm going to restart my share here so I can share a little bit of this video. I won't share the whole thing, but I'll share a little bit of it. So they read about this antenna tuner, and they said it could tune anything. So they decided they were going to prove that.
All right, so ever since I got this MFJ tuner, it said its thing was it can tune up anything. Do you remember reading that?
I think I remember reading that.
And I kept thinking, oh, it'll tune up anything. This was 3 years ago. No, 2 years ago. I was thinking, if it can tune up anything, I could tune up anything. So that's what I'm going to do today. Try to do today. So we've got the normal setup with some coax. And then I've got some counterpoise and...
Some salt water
Oh, that's for later.
for making noodles.
That's later. But yeah, right now we're going to try...
So what they do first is they load up the backstop here and make contacts with it. Then they create a wet noodle out of a piece of rope that they soak in salt water, and they make contacts with it. And they get very low SWRs with all of these using the antenna tuner. So that doesn't mean that these compromises don't work. And unfortunately, when you read the literature or you read ads, you'll get a lot of subjective and useless statements. I worked Slovenia with my first contact. He gave me a 5.9 with only 5 watts. Well, I work with 5 watts all the time. I have about 115,000 QSOs, and I have 328 countries, and I can guarantee that the fact that he gave me a 5.9 doesn't mean anything. So that doesn't tell me anything about the antenna. It worked better than X, Y, and Z that I used last year. Sometimes our memories aren't that good. So all these things don't really tell you how good the antenna works. They're just anecdotes and not really evidence. Number 6, if the length of the antenna is practical for your property, we already talked about an inverted V, but you can also zig and zag. One of my first HF antennas was a 40-meter dipole in the attic of the apartment I lived in. It looks sort of like one of those Get Smart or Man from U.N.C.L.E. or James Bond movies with the lasers shooting all over so you can't travel around. But in this case, it was red wire insulation that ran all around my attic. It did work. It wasn't the best. And one of the problems if you do an attic antenna today is a lot of the newer building materials have metal components to them. So even if you don't have a metal roof, you may have some metal insulation in there or some insulation in the metal above your antenna attic. So your attic antenna may or may not work very well. I would suggest instead using the rain gutters. They work better than antennas. But you can zig and zag. You don't have to have your dipole running straight. Another thing that's a convenience for reducing size is a delta loop. And I have 2 links here on delta loops. First of all, this is not an inverted V, this is a delta loop. And in this case, the delta loop has a triangle, and the wide part of the base is down low, and we're feeding it over here in the corner. The reason for that is if we turned this upside down and had the wide part at the top and the point down at the bottom, it would change the polarization. In this case, we have a vertically polarized antenna. If we turn it over, we'll have a horizontally polarized antenna. They both work, and don't worry about polarization on HF. It's not like on VHF and UHF. It's not going to be a problem, and I'll talk a little bit more about that later. The reason why you probably want to do the vertical polarization is you can have it much closer to the ground without interfering with the takeoff angle of the antenna. So this only needs to be less than 10 feet at the base here, and this needs to be whatever depends on how big an antenna you're doing for which band, but that you can get by with a 30-foot or even sometimes a 20-foot pole here to hold this up. Feeding it on the side here will give you vertical polarization on it. These 2 links go into great detail about building and using loops. Full wave loops, both horizontal, as in the case of this is a full wave loop. Different types of loop shapes. Talks about the impedance. You can always adjust the impedance and match it. That's not a problem. how different shapes are fed at different points, and a lot of good information on building some loops, both horizontal and loops turned on their sides. The second one is from a German author, and it talks about his specific project for a 40-meter DX antenna called the 40-meter Delta Mono Loop. This is a one-band antenna, but the nice thing is you can scale it for any band you want. So notice here he has a height of 36 feet. If you want to do this on 20 meters, you can get by with a height of about 20 feet. So this is a great portable antenna for out in the field. You can build this Delta Loop, use one single support such as a push-up fishing pole, and be able to have a great antenna. Delta loops tend to be quieter than verticals, less atmospheric interference. I mentioned earlier that you want to get the antenna up at the right height. Sometimes you can get a dipole up too high, but don't worry, you're probably not going to do that, except for maybe on 6 or 10 meters. It's not going to be a real problem. When you notice, for example, on 40 meters, how many of you have a dipole up at 68 feet? Kind of hard to get it up there unless you have some real nice tall pine trees or something. So more of us have antennas at 30 to 40 foot height, and that's not a problem on 20 meters. It's not even that bad of a problem on 40, but that just means you're not going to get as great a performance for long distances. If height is impractical, think of inverted V's, because they only require one support, or an inverted L, which only requires 2 supports, but the 2 supports can be different. And inverted L's are very popular on the low bands. Now let's talk just a little bit about VHF and UHF, because they do work a little bit different, and they are important, but there's some differences. The first thing is height is everything you can get. You can't get a VHF, UHF antenna too high in the air for the most part. The other problem is you want to make sure the polarity matches. So if you're using a horizontally polarized antenna to another horizontally polarized antenna, you have much better performance. But if everyone else is using a vertically polarized antenna and you have a horizontally polarized antenna, you can lose quite a bit of your signal. That doesn't mean it won't work, but that means that you're, again, fighting against the odds. By convention, FM signals use vertically polarized antennas, digital and single sideband stations use horizontally polarized. But I operate the VHF UHF contest every year, and I operate on FT8, and I have a vertical diamond or comet antenna on the roof. Does it work? Yes, it works. Would it work better if I had a beam? Oh, it would work a lot better if I had a VHF UHF beam, but I don't stop it from letting me get in there in the contest. Now, polarization is not important for HF antennas as far as the 2 polarizations matching. It's important for other purposes, but not for matching with other stations using, because once it bounces off the ionosphere, all bets are off. You don't know what the polarization was because it will get skewed and scattered and twisted around. Now, the next thing is a chart that gives you a lot of information, and it's antenna choices, both pros and cons. And I originally put this together in 2020 for our local club. Some of you may remember what happened in June of 2020. It was the first field day when we didn't get together as clubs for the most part. So all of a sudden, people couldn't just show up at the field day site and start operating. They needed to put up an antenna at home. So I put this together originally with the abbreviation of portable antennas, so tiny.cc port ant. But this basically talks about the pros and cons of different types of wire antennas, verticals, beams, magnetic loops, integrated antennas, mobile antennas. And then for each of these, I have a section with articles, how-tos, videos, and even in some cases, some examples of commercial antennas if you don't want to build your own. So these are all information on half-wave resonant, non-resonant dipoles, resonant and non-resonant end-feds, inverter Vs and slopers, wire loops, verticals, beams, stealth and indoor antennas, 110-meter antennas, 160-meter limited space antennas, magnetic loop compact transmit antennas. These are the magnetic loops that a lot of people talk about. They're not truly magnetic loops. They're actually compact transmitting loops. Integrated antennas. That's the rubber duck on your HT, for example. Mobile antennas, VHF, UHF, general antenna resources, a video from Mike KB9 VBR on portable antenna kits, and an article from The Villages, which is a amateur radio club in the middle of Florida, and they have a lot of home let's get the right link here. They keep changing the link on me. They have a lot of homeowner association rules, so they're constantly, I'm going to change this link again. So they're constantly dealing with that aspect. So what they did is they went through and they put together a bunch of information on stealth antennas, and then they grade each one based on a number of things. So here's the flagpole antenna. They have a grade for how well it works on the air, how stealthy it is, whether it requires an antenna tuner, how difficult it was to install, how bad the cost was, and then they graded on all the bands from 6 meters to 160. So you see, for example, the cost was pretty high on this flagpole antenna, and it worked pretty good on 10 meters through 17. It worked even better on 20 through 30, worked okay on 40, and not too great on the lower bands. So they do this for flagpole antennas. They do this for, there's a bunch of stuff on flagpoles. Let's get past flagpoles. And they have screwdriver antennas. They have patio antennas. And they have this big chart right here that has all of them in one place. So again, that's available, and I'll fix the link in the slideshow after we're done here so you can get to that. VHF, UHF antennas, just a few more things on that. One of the things is you can improve your HT by simply adding about a 17 to 19 inch piece of wire, either grounding it on the metal case or putting it at the base of the antenna. It's called a tiger tail, and it gives you a significantly better ground plane than your hand and your arm do. But doing something like a simple roll-up J-pole antenna made out of open wire feeder is a great way to have a great signal when you're operating portable. You can throw a string up into a tree or something and hold this up, attach it to your radio, and be ready to go. Or buy a simple Comet or Diamond fiberglass antenna. They're fiberglass disc cone, but there's actually metal elements inside of them. And I have a whole presentation on VHF and UHF antennas and a video on it. So if you're interested in that aspect of things, I have a bunch of information that's really good for technicians and for other people that are using VHF and UHF. So one of the questions that always comes up about antennas is gain. And if you can have an antenna with gain, you're going to be better off than an antenna without gain. Now, gain means that you're favoring one direction or directions at the expense of other directions. Gain usually means less wasted signal because you're putting it in the direction you want. The direction most of us don't want is straight up. And it doesn't have to be a beam to have gain. Omnidirectional antennas, the longer it is, the more gain it has. So these 4 examples of diamond or Comet antennas, less gain, a little bit of gain, much more gain, a lot more gain. And notice they are longer and they're more expensive, but they're not that much different. So if you can get by with this taller antenna, you're going to get more gain in the direction you want, and that is towards the horizon with these cases of these. These are omnidirectional, so the gain works in all directions, but what you're not doing is not shooting it straight up in the air. Adding a beam gives you even more directivity and more gain, and it's very easy with a small antenna on VHF and UHF. It gets much more difficult when you start increasing size. So on 40 meters, these elements would be 66 foot in length, and you don't see a lot of 40 meter beams. There are some out there. Again, K3LR has a series of 40 meter beams on a tower, so they can switch between the different heights. Now there's other things you can do too. You can build a simple VHF UHF dual band for satellite use using a piece of wood and some aluminum rods. You can build a Moxon. A Moxon basically has the ends folded back on your beam, and you can do something like this for 10, 6, 12 meters very easily and very compactly. I have a link here on the sizes you need for a Moxon antenna. You can put in the frequency and it'll give you the lengths for each of the components. Now, here's my antenna farm.
Power that is just in the bottom of the screen now. We're coming up on the 2 4-squares. These are phased 4-squares for 80 meters, and each one of those verticals is about 75 feet tall. Here's the 40-meter tower, and we're going to go on top of it for the moment, but we'll come back and take a
So this is a 40-meter stacked array. This is not my system. This is K3LR
look at
over in West Middlesex, Pennsylvania, which is about 50 miles east of me. So this was my real antenna farm before last August, before the tower got blown down. I was lucky enough to have a 50-foot tower, and I had a 3-element, actually it was a log periodic beam. It was 3 to 4 elements on different bands. It covered everything from 20 meters through 6 meters, and it also worked as a rotatable dipole on 40 and 30. Not very well for that, but it worked great on the other bands. I had an 80-meter and 160-meter sloper underneath it, and I had my 43-foot vertical hidden in the trees here. Since the storm, the tower is gone, and I moved my 43-foot vertical out here into the open, and that's all I'm using right now. And I really miss it on 10 meters and 12 meters, it's extremely, but I also miss it on 160 and 80, even though I can tune up this 43-foot antenna on 80 and 160, nowhere as good as the slopers. This 160-meter sloper has worked 80 countries with 5 watts of power and worked all 50 states. The 80-meter slopers work DXCC with 5 watts. This is a little bit, this shows you my antenna a little bit differently. This tree has been gone for quite a while, but this picture still shows it. So this is what I'm using right now, DX Engineering 43-foot vertical with an antenna tuner at the base for 160 through 10 meters. It's a horrible antenna, as I said. But in the first 100 days that I was using it, since my tower came down, I got worked all states, 157 countries, and 36 CQ zones. Since the beginning of January, I worked 175 countries on it this year alone with 5 watts. So here's some resources, some rules of on antennas for beginners from the American QRP Club. Antenna efficiency, it's a great video to watch. Ham radio vertical antenna sizing and efficiency by Tim G5TM. Here's my presentation on portable operations, including portable antennas. And then sometimes it's not the antenna's fault. So don't blame everything on the antenna. There's things we can do as operators to be more successful no matter which antenna we're using. And I have a whole presentation called How to Make That QSO Get in the Rhythm, Know the Rhyme, and Dance the Dance. And you can go out and see that, and you can also watch my video. Another one here for testing your station, seeing how well you're actually getting out without having to ask someone how well you're getting out. There's ways that you can get things like the reverse beacon network to tell you how strong your signal is. And then another one on top secret techniques for working DXCC and worked all states. If you're new to HF, W6DQ, Dennis Kidder, and myself put together a 4-part series. There's over 5 hours of recorded video, and there's a slideshow with 100 or 200 and some slides in it for all 4 weeks. You can watch all of these and get a lot of information on getting started with HF, including antennas. There's also a series on VHF, UHF, you're just getting started with that. And again, for links to all the materials I showed you tonight, tiny.cc/worst-ant, or I'll leave the QR code up there and you can shoot it with your phone, and that'll give you access to this slideshow and all the links in it. And I'll go ahead and take questions. I'll leave that on the screen for a few minutes. I also have, I'm just going to flip for 1 second. I also have another slide at the end here that has a link to all of my slideshows and all of my presentations at tiny.cc/K8ZT-P, or you can go to my website and there's a link that says Anthony's presentations. And you can see I just have a few presentations, and most of these have slideshows and videos of me presenting them. So I'll go ahead and take questions, comments, complaints, etc.
All right, well, thank you, Anthony. Any questions for Anthony?
Thoughts on the G5RV engine?
That's always the first question when I give this presentation, because people think I'm going to say the G5RV is one of the 10 worst antennas. First of all, the problem is most of the antennas that you see that are advertised as G5RVs are not truly G5RV antennas. Second of all, the G5RV, when it was originally designed by G5RV, was designed as a 20-meter antenna that was fed with tube transceivers. So SWR was not an issue. It was also fed with open line feeder. It wasn't fed with coax. So what we see often described as G5RV antennas, if you simply do a search for G5RV, you're going to see a lot of what are referred to as mono band horizontal antennas. Wait, put that in. Let me type that right. And when you start looking at some of these, you're going to see that some of them, like this one right here from MFJ, does use open line feeder. And with that, if you can run that close to your shack, you can actually use this on multiple bands with an antenna tuner, and it works pretty well. This antenna worked easily. But if you take the same antenna and you replace it and use coax all the way to the shack, you won't get the same performance. There's nothing magical about the G5RV. There's a lot of better dipole type antennas that can be used for multiple bands. And one of the tricks for these is if you can feed it with open feeder back to the shack, they're great multi-band antennas and very low loss in the twin feed. You can use a bowline to convert that to 50 ohms at the shack and use an antenna tuner with it. So there's nothing wrong with the G5RV except for the fact that most of the G5RVs we're talking about aren't really G5RVs, and that wasn't really the original design parameters. So take a look at this, at the list of the antennas here in the tiny dot antennas, and go up here and take a look at some of these half wave resonant dipoles and non-resonant dipoles, and you're going to find a lot of antennas that work very similar to the G5RV, in many cases outperform it.
All right, any other questions? Yeah, Stephen.
That was a 43-foot vertical. Is that a guided antenna, or is it?
No, the 43-foot vertical is not guide. It is a standalone antenna. It's rather hefty. It's 2.5 inches in diameter at the base, and it goes down to about, I think, 3/4 of an inch at the top. You can see it's got multiple segments in it, and they're all pretty short, and this wobbles around in the wind. It looks sort of nasty in the wind, and we had a 70-mile-an-hour wind this afternoon come through, and it was wobbling all over the place, but it is not ground. It is not guide. When I purchased this, it was about $300. It's now about $5 or $6,
I believe it.
maybe $6 even.
I have a 5E TV, which is about half the thing size.
Yeah, and there are some other 43-foot verticals out there, not just this DX Engineering one. This is a rather stout one, but there are some out there. SV9, which is now out of business, used to make a pretty decent one that worked, but they're no longer making them. One of my main antennas I use for portable operations is a 31-foot vertical that collapses down into 4-foot. It's basically a aileron for the aircraft industry, and it collapses down. It's a fiberglass pole, but there's a wire that runs up the middle of it. And I have two of them. One that has a coax connector at the base. I can hook up coax to it, and it works great on 40 meters. The one that works better is the one that has just two ends of wire there, and I hook it up to my bowline and my tuner right at the base, and operate the tuner at the base of that, and I can use it on all the bands very easily on 40 through 6 meters. Putting the antenna tuner at the base of a vertical, a non-resonant vertical, can be very helpful. Now with a resonant vertical, that's not necessarily the case, because you might not even need an antenna tuner. So like the Butternut HV9 is an example of another vertical that covers multiple bands. But it's a little more complicated in the fact that it has matching units throughout the antenna, and different bands work differently. So you see these side matching things here. One of these matches 15 meters, one's used on another band. There's these coils, and there's also doorknob capacitors here, which where that blue nut mark is at. This antenna works pretty decently on 80 through 10 meters. I had one of these for years. They gotten up in price a little bit. They used to be about $600, but you can find these a lot of times at Hamfest. And that's one of the things about antennas. Antennas themselves don't typically wear out. Something like this Butternut, the problem is these doorknob capacitors can wear out, so you have to replace them. An antenna like the Hustler HB5 is a very basic antenna. It uses traps in it. There's nothing horrible about traps. I mean, traps have gotten a bad rap over the years. They do eat up some of the energy. The important thing with all these verticals I'm showing you, though, is to put out an adequate counterpoise. So for my 43-foot vertical, I have 16 counterpoise lines that are each 30 foot plus in length. I'm sorry, 20 foot plus in length. Let me mention one other thing about vertical counterpoises while I'm on the subject. If you lay them on the ground or bury them slightly in the ground, the length doesn't matter. Longer is better, more is better, but there's no exact length to cut them to because they're not resonant. The reason they're not resonant is once they're laying on the ground, it detunes them. Now, if you raise an antenna up a little bit, like for example, let's say you put this on a 4-foot pole and raised it up above ground and then ran radials, your counterpoises that were above ground, then they need to be tuned specifically to the resonant frequencies. There, the length does matter, and you can get by with less with a raised antenna than you can with a ground-mounted antenna, but they have to be tuned, and they have to have tuned ones resonant for each of the bands you want to work on.
I have a 5B TV, but I don't have any counterpoise wires. It has worked really well for me, though.
I'll tell you one trick you can get away with a 5B TV, and this is what I did when I first moved into my house and didn't have time for counterpoise. If you have a chain link fence in your backyard,
I do.
Mount it at the corner, mount it right on the chain link fence in one of the corners. Make sure you tie together your elements by putting screws into the different things that are just force fit, and it provides a very good ground poise. I do that quite often when I'm operating portable and I go out to a location and I don't have time to put down radials. If I have access to a chain link fence, a backstop, a big metal road barrier, anything along those lines. I'm always tempted to use railroad tracks, although you're not allowed to do that, so I don't do that. It's also dangerous. But I think I've always wanted to go out and try the tracks that are not being used near my house and see how that would work as a set of radials. But yeah, you can get by. Again, you need some sort of counterpoise. You're always going to have a counterpoise even if you don't install one, and the counterpoise is going to be the poor soil in your yard if you don't put anything at all. Or it's going to be the coax shield going back to the shack.
Steven?
Another question, you spent some time on counterpoise, and I'm starting to see out and put in sites and different locations, Faraday cloth spread under a vertical rather than running wires at all.
You can.
Quite a bit of good vibes about it. Fairly small, easy to deploy fast. What are your thoughts on that?
It's more expensive in the long run to do the same amount of coverage because the coverage doesn't have to cover every square inch. And one of the things that a lot of people don't realize about radials, it's not a lot of work. All you need to do is cut the grass short and tack them down temporarily, and you'll be surprised in about 3 months the sod will take over and bury the radials and you won't have to worry about them. Now my wife is giving a hum on the other side of the house because we also have a problem in our backyard with some of our ground sinking a little bit, and that leaves the ends up in the air sometimes. So she's hit one with a lawnmower before, but I don't tend to hit them with a lawnmower. But I have used a small Faraday cloth for portable operations, and it is convenient because I can roll it up and put it in the car very easily and then spread it back out. But I don't think it's as big as I would really like it to be.
The counterpoise wires, do you attach that to the base of the antenna, or just need to be next to it?
No, they need to be attached. And you need, not only they need to be attached, it needs to be a low resistance attachment. So you want to spend the time and make sure that those connections are just as good as the connections to the antenna. And that's one of the things that happens a lot of times. People will put counterpoises on in such a fashion that they get corroded at the base, and then they're not really working well. And the other thing that can happen too is corroded, loose connections, anything like that can introduce noise into your system.
Mm-hmm. It also affects your SWR when you get these connections.
Yes, but sometimes you won't even notice it because they're just intermediate enough. On that 80-meter sloper I was showing you, I kept getting interference, and I thought it was some sort of interference because it would sort of cut my signal out. But what it was, when I brought it down, is there was a loose connection at the end of the antenna, and when it flexed in the wind just a little bit, it would open up for a second and then close, open up for a second, then close. So I was able to make contacts on it, but people always said, well, there's noise on your signal. Well, the noise was not the noise, it was the absence of my signal when it would cut out. So yes, you want to make sure that all the connections are done well, and you want to make, corrosion is not your friend. But the other thing too is be careful the way you remove water. You don't want to seal things up so that, for example, if you seal the bottom of your vertical up, water will seep in at the joints. It'll go down to the bottom, and in the wintertime, that water can freeze and it'll actually blow the aluminum apart. You'll see it rupture the aluminum from the ice.
Mine's mounted on a galvanized pipe, but it's not sealed, it's open, so
Yep,
any water that gets into it can flow out.
exactly.
But I'm thinking that I need to move my antenna because a tree is coming pretty close to contacting it. So I figure when I go to do that, I might as well, inspect the antenna while it's down and making adjustments, maybe add counterpoises.
And it's not a bad idea if you can take an antenna down periodically just to go through and tighten things up and check things. For example, on that butternut I was talking about, those doorknob capacitors, I had one of those go bad, and you could not tell it until you actually went out there and pulled on the one element, and then you noticed it was broken. And it made a significant difference. So you do want to inspect your antennas periodically. Now, with an antenna that's mounted up high, we have a new advantage that we didn't have before, and that's inspecting with a drone. So if you can get a drone up and check the joints and things like that, sometimes it'll save a trip up a tower and save taking an antenna down. But with a vertical, I'd suggest lowering it every couple of years, checking all the joints to make sure they're all strong, make sure there's no problems. One of the things that also happens that clogs up some of the drain holes is you'll get spiders that will get in there. I had a switching box at the top of my tower, and it had drain holes in it to let the moisture out. The problem is spiders got in those drain holes, and they filled it up so badly that the moisture just all sat in there and corroded everything.
All right, looks like we got a question online. Craig?
Yes.
Yeah, about the counterpoise, I kind of two questions. Is one, does it matter if it's bare or insulated?
No, not if you're laying it on the ground. Does not matter at all.
Okay, and then second question is kind of a two-parter. Does gauge of the wire matter, and then is it better to be stranded or solid?
The gauge doesn't matter until you get to really esoteric points and things. So no, for amateur radio use, it does not matter. If you're designing a broadcast station, yes, it does matter. If you're running 1500 watts, because most of the energy travels on the skin, so a lot of cases they use flattened radio, so they're getting more skin surface on it. I want to take back what I said though about putting it on the ground. Insulated actually works better as far as durability goes. So if you're going to put them on the ground, don't strip off the insulation. You're better off with insulation. It'll prevent some of the corrosion that takes place. Copper does corrode, especially if it's laying on the ground.
Does that make it like a capacitance then if you've got an insulator plus the dirt on top?
No, it doesn't. It does not. It's not a problem.
Okay, thank you.
All right, any other questions? Yeah, we got a question right here.
Yeah, go ahead, Rand.
What's your opinion of the DX Commander?
It's a vertical, and Colin does a great job talking. He's a very intriguing person to listen to. It's a solid antenna. There's nothing spectacular about it that you could not produce on your own. If you watch his videos very closely, he's very meticulous about making sure he has good radio fields. He's meticulous about all his connections. So the magic isn't in the antenna. The magic is in his way that he uses the antennas. So I think it's a good antenna. Basically, for those of you that don't know, the whole idea behind the antenna is it uses multiple segments for each of the different bands in a vertical configuration that are held together with plastic or other type of insulating materials. So basically what it is it's multiple verticals in one vertical holding. let me see if I can describe that. It's a vertical made up of multiple single elements. It's a good idea. I mean, there's a lot of things that we could theoretically do. You could have a vertical that changed lengths, and that's actually what they do with the the step IR vertical. What they do is they actually change the length, so they get resonance not by changing the antenna tuner, but by actually changing the length of the antenna to match the frequency you want to be on.
All right, we're getting kind of late. Let's do one more question. If there's one more question. Any more questions? We'll take one more.
Well, I'm going to answer the one question no one asked then.
All right.
The most important thing is not the antenna, it's getting on the air. I talked earlier about the worst antenna is no antenna at all. Probably the number, if I was going to add number 12 to the list, it's a lonely antenna that's not getting any RF ran through it because it's not going to make any contacts either. So get out, exercise your antennas, make sure they're working, get on the air. You'll be surprised, the more you get on the air, the more contacts you make. And hope to work some of you during the Ohio QSO party in August. I'll be on as K8ZT. I'll be doing Summit counties here, Uniform Mike. So I hope to work you on that. And I'll be on during OSPODA the first week in September or whenever it is. I'll be operating probably from Nelson Kennedy Ledges. That's where I typically operate from on that particular activity. So listen for me on the air. I'd love to work you.
All right. Well, thank you very much for the presentation, Anthony.
Well, you're very welcome. 73, hope to work you on the air.